everyone. Here are your notes for dividing binomial radical expressions. So if you'll remember, at the beginning of the week we did monomial radical expressions, so that was just one term. Now we're going to be looking at dividing radicals with two terms. So the first thing we're going to look at is actually this right here. So if you'll remember way back to when we were multiplying simply just binomial expressions, we called these a difference of squares pattern. Remember, because we have blank plus blank times blank minus blank. So same first term and same last term, just two different signs. That's a difference of squares pattern. So you'll remember if we multiplied them, if we FOILed them, we had 3 times 3 gives me 9. Do my adder term, so 3 times negative square root of 5 minus 3 square root of 5. And then I have square root of 5 times 3, so plus 3 square root of 5. And then I have square root of 5 times negative square root of 5, so minus, so square root of 5 times square root of 5 is just going to give me 5, right? Alright, so these two in the middle will cancel, minus 3 square root of 5 and plus 3 square root of 5. So I'm just left with 9 minus 5, and that gives me, that gives me 4. So in this difference of squares pattern, we have same first term, same last term, but just a different sign in the middle. And we can just kind of remember in our heads that these middle terms are going to cancel. So really, if we want to take a little shortcut, we just multiply first term by first term and last term by last term, and we're going to have a negative sign in the middle. But you feel free to write it out like this and then cancel your middle terms. This may just be a little bit quicker. Alright, so these are called conjugate pairs. The difference of squares pattern where we have same first term, same last term, but different signs, they're just called conjugate pairs or conjugates. So let's look at these little examples right here. It says find the conjugate. So I have 5 plus square root of 10. So remember, same first term, same last term, different signs in the middle. So this one's a plus, so this one will be a minus. So these two are conjugates. This is the conjugate for this binomial. This is the conjugate for this binomial. All right, let's look at this one. We have square root of 3 minus 8. All right, so remember, same first term, same last term, different sign. Have a minus here, so I'm going to have a plus sign. Those two are conjugate pairs. All right, and remember, if I multiplied them out, the middle terms I know will cancel simply because it is a difference of squares pattern. So all I really need to do is say 5 times 5 gives me 25. Positive square root of 10 times negative square root of 10 is going to give me minus, because positive times negative gives me minus. And then square root of 10 times square root of 10 just gives me 10. Remember how I solved that? Square root of 10 times square root of 10 is square root of 100. And what is the square root of 100? It's just 10. So that's where this came from. All right, so 25 minus 10 is going to give me 15. So that's where my thinking is going in these next few examples, all right? So the conjugate's going to be very important. All right, let's look at a quick example of dividing monomial radical expressions. So remember, the first thing we had to do was rationalize the denominator. Now all that means is we have to multiply by something equal to 1 to get rid of this radical in the denominator. So what I'm going to do is I'm going to multiply by the radical in the denominator here. This is how I'm dividing my monomial radical expressions. So 3 times square root of 3 times square root of 7, square root of 21, and then square root of 7 times square root of 7 is 7. So that would be my answer here, and that works out perfectly fine. Let's look at this example here, number 2. Now, if I tried it the same way, if I multiplied both sides, or the top and bottom, by the radical in the denominator, let's just look at what that would look like. So if I multiplied, we'll just say 7 times square root of 10. And then we have 9 plus square root of 10. So I'm trying to get rid of the square root in the denominator, right? So if, let's say I tried this, I would have 7 square root of 10 over, so square root of 10 times 9 is 9 square root of 10. And then square root of 10 times square root of 10 is 10. Uh-oh, I still have a radical in the denominator. So this method I used for dividing monomials here isn't going to work. Here's what I have to do. I have to multiply by the conjugate. So instead of just picking out this radical here in the denominator, I'm going to multiply by something equal to 1 still, but I'm going to multiply by the conjugate. So remember our conjugates earlier? Same first term, same last term, but different sign in the middle. So same first term, so 9, same last term, square root of 10, but different sign in the middle. So now I have that difference of squares pattern, right? Alright, so I'm going to do the same thing on the top because I'm multiplying by 1 now, right? That makes sense. They're the same thing being divided by each other. So it's just going to equal 1. Alright, now let's see if this method works. So I'm multiplying by the conjugate. Okay, so I have 7 times 9. It's going to give me 63. Then I have 7 times negative square root of 10. So minus, because I have positive 7 times negative. So minus 7 square root of 10. Over. Now, I could divide these out all the way if I want, or multiply these out all the way if I wanted to, or I could just use the little trick I learned earlier. But let's say I decided to multiply it all out. So 9 times 9, remember I'm just foiling here because I have two binomials. Just foiling. So 9 times 9 gives me 81. I have 9 times negative square root of 10, so minus 9 square root of 10. Then I have square root of 10 times positive 9, so that's going to be plus 9 square root of 10. And then positive square root of 10 times negative square root of 10. So positive times negative gives me negative, and square root of 10 times square root of 10 is just going to give me 10. All right, now remember what I said about those middle terms. They just cancel out, right? Because plus this term minus this term gives me 0. So I'm going to have 63 minus 7 square root of 10 over what's left on the bottom, 81 minus 10. It's going to give me 71. So that's my final answer. So the way to get rid of the radical in the denominator is to multiply, I'm having a little trouble spelling today, multiply by the conjugate to rationalize the denominator. I'm just going to put denom, but we'll know that that means denominator. All right, let's try another example of this. So we need to rationalize the denominator, right? I've got to get rid of that square root in the denominator. So what did I do last time? I multiplied by the conjugate. All right, so what is the conjugate of this denominator here? So this is 9 minus square root of 10. So I'm going to have same first term, same last term, different sign in the middle. And I'll do the same thing on the top, because that is equal to 1 then. All right, now I'm going to multiply. So I'm just going to, instead of distributing from here, I'm just going to kind of write this out using multiplication. So 7 square root of 10 times 9, right? Because I'm basically distributing here. And then plus, because remember I have 7 square root of 10 times 9 plus 7 square root of 10 times square root of 10. All right, over. Now remember last time I wrote out my middle terms. I'm just going to kind of skip that this time. So I have 81, and then minus square root of 10 plus square root of 10. So I know I'm going to have a minus here because negative times positive gives me negative. And then square root of 10 times square root of 10 just gives me 10. Alright, so if I simplify this further, I'm going to multiply in here my coefficients. So 7 and 9 will go together, right? Because this one doesn't have a radical attached. So 7 times 9 is 63. And then I have square root of 10 left over there. Plus 7 square root of 10 times square root of 10. So my coefficient here would just be a 1. So 7, and then square root of 10 times square root of 10 is 10. That's just going to give me 10 right there. So 7 times 10 is 70. So I kind of broke this down like this, if you're wondering where that came from. So 7 times this, which is 10, 7 times 10 is 70, over 81 minus 10, so over 71. All right, and that would be my final answer. If you wanted to, you can always, factor a 7 out here, but it's not going to affect the overall answer, so this is perfectly fine. All right, and let's look at one more example here. So I have the square root of, or negative 3 square root of 2 over square root of 3 minus square root of 5. So remember my first step, I've got to get rid of those square roots in the denominator. And how do I do that? I multiply by the conjugate. So same first term, same last term, different sign. So now I have that difference of squares pattern, then my middle terms will cancel. All right, and so I'll just write the same thing up top to make that equal to 1, right? Because the same term over same term is just going to give me 1. All right, so let's write this out again. I have negative 3 square root of 2 times square root of 3 plus negative 3 square root of 2 times square root of 5 over. Now remember, I'm going to skip that middle step here because I know my middle terms are going to cancel because these are conjugates, or they're in their difference of squares form. So I'm just going to multiply first term by first term. So square root of 3 times square root of 3. It's going to give me 3. Because remember, square root of 3 times square root of 3 is just square root of 9. And that is simply 3. So that's where that came from. All right. Negative square root of 5 times positive square root of 5. I'm going to have a negative there because I have negative times positive, and I'm going to have a 5 on this side. So now I simplify the top a little bit. I'm going to be left with negative 3 times 1 here, so negative 3. Square root of 2 times square root of 3, square root of 6, plus negative 3 times 1 here, so negative 3. Square root of 2 times square root of 5 is square root of 10. That's all going to be over 3 minus 5, which is just negative 2. So that would be my final answer. If you wanted to factor out a negative 3, like I said, that'd be fine. Cancel all the negatives, whatever, but this is totally acceptable. All right, so I forgot to square that answer. All right, so here are your steps for dividing binomial radical expressions. So a radical expression with two terms connected by addition or subtraction. So first you rationalize the denominator just like you did dividing monomials, except this time you're not multiplying by only the radical, you're multiplying by the conjugate. So I'll put a little note here. The conjugate is just difference of squares form. Maybe that'll give a little hint. And then you simplify. So you, in this case, you would finish multiplying and you add